These types of questions are very common when they're asking us for lots of different isomers. Key thing is it's telling us we're now looking at pentan 2-ol, not pentan 1-ol as we were looking at earlier. It tells us we're heating up with sulfuric acid and we're forming alkenes. So here we've got that elimination of water that we were talking about in the previous question. We know we're forming 3 different alkenes. Let's look at how this happens. This is pentan 2-ol, which we're starting with. The OH group is on the second carbon. When alkenes form, the OH, so this bit here, and one of the adjoining hydrogens are removed. Now that gives us 2 possibilities. We can remove this and this, or we can remove this and this. So the 2 possibilities that we have when the double bond is introduced are that the double bond comes between the second carbon, where the OH was, and the first one, or that it comes between the second carbon, where the OH was, and the third one. So these are the 2 possibilities, 2 isomers. But when we look at this one, because we've got a double bond attached to a carbon on each side, and the carbons on both sides of the double bond actually have 2 different groups or lots of atoms, that means that this one here can have EZ isomerism. This one can't have EZ isomerism because effectively, if we think it through, this has got 2 hydrogens on. So this carbon does not have 2 different groups attached to it, which is one of the criteria for having EZ isomerism. This one can have EZ isomerism, so we'll look at that one in a little bit more detail, but we know that the one that does not have EZ isomerism, i.e. N, must be this structure. This is a structure for N. Now what we find lots of students make mistakes in is by adding in extra bonds here, and I've just indicated that with a squiggle. So once you've done your isomer, or once you've done your structure with your double bonding, you need to go back and count up how many bonds there are attached to each carbon. So 4 here, this one's got 1, 2, 3, 4. So you're just going through and you're double checking. It's a self-checking mechanism to make sure that you're not making silly mistakes. We've got L and M. We don't have any additional information on L and M, just that they're stereoisomers of each other. So we have got 2 possibilities. Now you'll notice that I'm drawing it differently here, and I find it easier to draw it with this slightly different structure when we're doing EZ and cis-trans isomerism. I do the carbons that are attached to the double bonds, and then I have everything coming off at an angle, and I group anything that's attached. So here, if we look at the structure we had here, I've got the carbon attached to one CH3 group, and there will be a hydrogen attached there that we've not included in. And then here, I've got this carbon attached to 2 lots of carbons with the hydrogens and a hydrogen that we haven't got added in here. So what I've got is my structure with my CH3 and my structure with my C2H5. And I just made a silly error by putting C3H7, which I've changed. And then my alternative structure here, where I've left the left-hand side exactly the same, but you can see that I've changed around, I've switched around my right-hand side.